Alright, so in Chapter 2, Section 5, kind of the second half of Chapter 2, um, there's some more finding the derivatives and how we find derivatives, more techniques. Like on number 3, now this is a good old quotient rule. Low d high minus high d low over low squared. So this one should be normal. Number 4, now it's a squared, so we could FOIL it out, distribute. But like if this was to the sixth power, would you want to distribute that out? And the answer is no, you would not. And so this is where the substitution rule comes in, the chain rule. So I'll do a supplement on this one, but basically we're just going to get rid of this 5x cubed plus 4, replace it with a u, and so we're going to take the derivative of u squared, which would just be the power rule and be a 2u, but you always have to multiply by your derivative of what you said u was. So we're going to have a u squared here, but then when we derive that we get 2u, but we're going to multiply it by the derivative of u, and then we just do some substitution. So we'll see one like that in the supplement. 5 is similar. 6, this is just something raised to the 1/2 power, and so that's what we treat it as, something. Let's call it u raised to the 1/2 power. And this is a way that we can find more derivatives more easily by using this substitution rule. This one looks like a good old product rule, right? Because it's x times the square root of this thing. So to find the equation of the tangent line, we have to find the slope at a particular point. And at 2, looks like they found the slope to be 20/3. And so there's some Desmos things that you can do, because on Desmos, if we have this equation, x times the square root of x squared plus 32. Let's see if I can type that in right. X times the square root of x squared plus 32. Whoops. Make sure I got that right. Sweet. And so here's my picture. Don't know exactly what it looks like. Have to back it up a little bit. Well, it looks a little linear, but I imagine if we back up, there's going to eventually be some curve to it. And I see the curve there. Alright. But I could always graph my derivative function. So I'm going to call g of x. This is going to be my derivative, d dx, of f of x. And so this is actually a graph of my derivative function. It doesn't derive it for you, but it does give you the graph. And so if I wanted to find out the slope that they gave me, so when at the point 2, f of 2, right, which we totally could graph that, 2 comma f of 2. So we see that point on our original graph, this red graph, right? But what is the value of g of 2? Because that's what I'm interested in. What is the slope of this line, of the tangent line right there? And so I just plug that into my derivative equation. That blue, this is the graph of the derivative. But I just want to know what is the slope. So this is my slope equation when x is 2. And I get 6 2/3. Well, if we change 6 2/3 to a mixed number, I bet you we get that 20/3. So from there, it's just finding the intercept value. So I'll do a supplement on that one too. And then on number 12, more of a word problem. So this one would be doing a substitution step where this whole thing underneath here would be our substitution. So we'd say u equals all this, and so basically we have 0.05 times u to the 1/2, and we'd use that power rule to get us there, but also multiplying by our du at the end. And then lastly, if we're finding a rate, that means we would just be plugging in 11,000 in, Um, when the population of the community is 11,000. Okay. So, and is the number of residents in thousands. So if we have 11,000, remember, because I always mess this up. So if it says number of residents of the community in thousands, so that means if our community has 11,000, we better type in n equals 11. So that's something just to make sure. I always mess that where they give a variable and they give it units, thousands. So if they tell us the population has 11,000 people, we need to type in 11 to get our answer. So I'll give a supplement on some of those chain rule, the substitution steps, and that should give you a head start on chapter 2, section 5.